All right, good morning, folks. Welcome back to your chemistry class. So the purpose of this recording, got another great question about conversions. This question is, okay, so I've got a conversion question. Conversions. I figured out my start. I figured out my end. I figured out my units. Figured out my numbers, my conversion factors. This question is, how do I do my math? And I'm so glad you asked, and let's just get in and do it. So we'll do an example question of something like, how many? This is your keyword, this is what you're solving for. So how many, let's say, grams is, let's do 6.3 moles of carbon dioxide, because why not? This is a conversion question. Nothing is changing here except the unit that you're using. So we're going to convert from the start, which in this case is, it's always your number. Here your number is 6.3 moles of carbon dioxide. This is where you're going to start. It says how many or how much, how many grams. This is where you're going to end. And off we go. First step is put these units where they go. So we want it to equal grams when we're all done. And we know that we're starting with moles. We're starting with 6.3 moles of CO2. We're going to put that over here in the start spot. So we're starting with our number and its units. We're ending with the units we want. In the middle, this video is assuming that you've got the first 4 steps figured out, including in the middle, we've got some sort of conversion, and we need the units first. Take the units that you're starting with. Moles of CO2. You want to get rid of that starting unit. You want it to cancel out. So we're going to take it from the top to the bottom of your giant fraction, cancel it out. What you want to solve for is grams. So put that unit on top, grams of CO2. And, okay, got the start, got the end, got the units for the conversion. Let's get the numbers for the conversion. Did a whole video on this yesterday. We made a bunch of flashcards. And actually, let's use the flashcards that we made yesterday. So I think I called this the flashcard method. So we've got a bunch of cards, and they have all sorts of conversions on them. And oops, what we're looking for here is which units are we actually working with. And again, I'm kind of assuming, like, okay, let's just do it. So here are your flashcard options. Are we looking at liters of gas in moles? Nope, we're looking at grams and moles. Just to show this again, grams, moles. Okay. Moles and liters of gas? Nope. Moles and atoms? Check it. Grams, moles, atoms? Nope. This is not what we want. Grams and moles. Okay. That kind of does match. We're starting with grams. We're ending with grams. We're starting with moles. This could be it. Here's another one. These are both about grams and moles. Let's hold on to those. Atoms and particles and moles. Nope, that's a different conversion. Okay, so here are 2 flashcards with the units of grams and moles on them. And let's figure out which one we want here. We want to end with grams, and we want to start with moles. So the unit that you're ending with, you want on the top of the fraction of the conversion. So find where your ending unit is on top, and your starting unit is on the bottom. Well, here we've got moles on top and grams on the bottom. That would not give us grams on top and moles on the bottom. This is not what we want. Here we've got grams on top and moles on the bottom. That matches what we want for our conversion here. Okay, so the units, drive the bus. You found the flashcard where the units match. Flip that over, and this is going to tell you where your numbers come from. Pull the molar mass from the periodic table. It will be that many grams of a particular thing for every 1 mole of that thing. Okay, so some of these numbers we can copy into our conversion factor already, because we know that whatever our molar mass is, it's going to be that many grams of the compound for every 1 mole. We're going to be solving for 1 mole. That's where your 1 goes. Okay. Good. Almost there. Still looking at this molar mass. We're solving the molar mass in grams of carbon dioxide. So what you want, you're solving the molar mass of carbon dioxide. Has 1 carbon and 2 oxygens. Each carbon has a mass of 12.00. Here's my favorite example. Okay, so the mass of each carbon is, I'm going to show you how I got that, 12.01 grams per mole. So each carbon is 12.01 grams per mole. Each oxygen is 16.00 grams per mole. We've got 1 carbon, so the total mass of the carbon is 12.01 grams per mole. We've got 2 oxygens, so the total mass of your oxygen is 32 grams per mole. You can plug that into your calculator. Add those together, because in total we've got 1 carbon, 2 oxygens. Okay, I'm getting into detail here, and you're like, I already got my molar mass stuff. That's that many grams per every 1 mole. And those units, again, the units are the key. Moles, in this equation, we're on the bottom, so the 1 follows the moles, 1 followed the moles. Good. In this case, grams are on top. We found how many grams per mole. We found carbon dioxide's molar mass, 44.1 grams per mole. 0.01 grams per mole. Okay. And here we are looking at, once we've got this written, how do we do the math to solve it? All right. So this is a multiply sign here. So in this math equation, we're going to multiply these 2 fractions with each other, and that will equal our answer. Okay. So let's do it. We are going to multiply, there's kind of 3 steps here. Multiply the top. So multiply, I'm just going to use the little sign to save some space. Multiply the top. And then multiply the bottom. And then take the top and divide it by the bottom. That is how to solve the math. Let's do it together. So on the top of this fraction here, let's do the math in a different color. I should have, okay, this is the math part. Math. Here, our top is 6.3 times 44.01. And you're going to take your calculator and you're just going to type that in. So we've got 6.3 times 44.01. So those are the numbers from the top, and I'm multiplying them together. That gives me 277.263, 277.263, Okay, so those are my numbers on top. That's the top. And next, we're going to multiply all the numbers together on the bottom. So on the bottom, we've got 1 times 1, and feel free to do that in your calculator. Anything times itself is itself. 1 times 1 is 1. Good, good. That's the bottom. And in our third step, we're going to take the top and divide it by the bottom. So top divided by bottom. Here, 277.263 is the top. We're going to divide it by the bottom, which in this case our bottom is 1. That's something divided by 1. You can plug that in if you want. So 277.263 divided by 1 is 277.263. So that's your answer. Your units are totally critical. We're solving for grams of CO2. Pick that at this number by itself is wrong. This number by itself has no meaning whatsoever. We're getting like metaphysical or whatever. There's nothing. This is just a number. And in math class, numbers being numbers is like a thing. Science applies to actual things. Numbers are are totally superfluous unless you say what they are. So if we say it's this many grams of CO2, now you're telling me what it is. Now this number has meaning. Okay, so there we go. We found our answer. You are likely thinking to yourself, or possibly, I have no idea, but you're possibly thinking to yourself, this number looks a little messy. There's a lot of decimal points, and last quarter we did all this stuff on sig figs, and whether or not, that may be in your memory that you did some sig figs last quarter. So let's do it here. You are not required to do sig figs. I would accept this as a correct answer because you crunched your sig figs last quarter. I'm going to let all of that go with quarter A. In quarter B, this is fine. I will accept this as a correct answer. For those of you who are going on in chem especially, this is not actually a correct answer, but here what I want you to really be thinking about is the conversion itself. So I'll always show, I call them the finishing touches. And yellow does show up. Finishing touches. Finishing touches. And there's 2 finishing touches. The first one is sig figs. So again, technically we should be doing sig figs every single time. And so let's do it. To do sig figs, the way that I teach them, you're looking for how many significant figures did you start with, and this is how to do them, but I think it's kind of a simpler way to think about it. There's probably a lot of ways to think about it. So how many sig figs do you start with? Go all the way back up to your original question. How many grams is 6.3 moles of CO2? Okay, that's where you started. For your sig figs, take that number and say, how many sig figs here? Well, everything that's not a 0 is definitely significant, and zeros get funky, and I'm not going to do that right here. But these are both not 0. Cool. So we have 2 sig figs. All right. Which means in our answer, in our starting spot, we had 2 sig figs. So in our answer, we want 2 sig figs. We want 2 sig figs here. And to take this whole number and write it so that you have 2 sig figs, take the biggest 2 place values, keep those place values, round using the next one. So that x means you're going to round with that 7 because you want 2 sig figs. So keep the biggest 2, round using the next one, 7, everything 5, 6, 7, 8, 9 rounds up, 7 rounds up, So this 7 is going to round up with significant figures. Your answer looks like this. That 200, definitely significant. The tens place rounded up because the ones place was a 7. Again, don't worry too much about your finishing touches. If you're looking at this and you're like, yep, got it, totally go for it. If you're looking at this and you're like, what on earth is she talking about? Don't worry about it. This is also a correct answer. For your second and final finishing touch, scientific notation. And again, I'm thinking that you crunched a bunch of scientific notation last quarter. I will not evaluate you on scientific notation this quarter because you were evaluated on that last quarter. But scientific notation would say we want to write this so there's one number in front of the decimal place. Your decimal is implied here. It is not written, which is totally important. In math, it doesn't matter. In science, it does because it describes how precisely you measured something. Again, that's quarter A stuff. But we're going to pick up that decimal and move it 2 times so that there's only one number in front of the decimal. Keep the other significant numbers. That 0 is not significant, but I'm not going to go into that a whole lot here. But these are not the same. We moved our decimal 2 times, so we're going to say times 10 to the 2. Keep that unit. Again, with no unit, that number is meaningless. And there you go. So your technically most correct answer would be this one right here. However, this is correct, this is correct, this is correct. This in scientific notation without sig figs would be correct. Most of what I'm looking for is the actual conversion. Okay. I want to give you a second example so that you let me know if you have other questions. I think the primary point of this video was this math step right here. Again, every single time, start with the start, put the starting stuff in the start spot, put the ending stuff in the end spot, do the units all the way across. Once you've got your units, then you can use your flashcards or however you think of it. Once you have your units, that tells you what the numbers are. Okay, so you got your start and your end, you got your units, you got your numbers. This video is about the math step. The math step is this right here. Multiply the stuff across the top, multiply the stuff across the bottom, take the top divided by the bottom. That's your math. Alright, enjoy. Let me know your other questions. See you soon.